Okay, today in regular chemistry, we're going to do some geometries of some molecules, so molecular geometry. So once you have correctly drawn the Lewis structure for a molecule, you can predict the geometry or shape by using something called the VSEPR model. VSEPR stands for valence shell electron pair repulsion. And it simply tells us that valence electrons surrounding an atom will repel one another so that the orbitals containing these electrons are oriented as far apart as possible. The repulsion among electron pairs on a molecule will result in atoms existing at fixed angles to each other. The angle formed by any two terminal atoms are those bonded to the central, is called the bond angle. Okay, so we're going to put these into two groups. We're going to talk first about molecules that do not have lone pairs on the central atom. Then we're going to do molecules with lone pairs on the central atom. Okay, so we have a general form for an AB2. So A is your central atom, B are your bonded atoms. So we just simply are saying two atoms are bonded to your central. These molecules will have a linear shape or geometry, and the bond angle will be 180. Here it tells us A represents the central atom, B are the atoms bonded to the central atom. This occurs only when only two pair of electrons are shared with the central atom. And they will have something called sp hybridization. So I'll explain this hybridization, how you get that in a second, then I'm going to show you just a simple way of doing it. Okay, so we're going to draw BeCl2, so I'm going to have to use another sheet of paper since I didn't leave enough room. So we have BeCl2. You'll need your periodic table. Beryllium has 2 valence electrons. Your chlorines each have 7. Okay, so we're going to do our electron count just like we did in yesterday's lesson. So beryllium has 2. The chlorines each have 7, so 7 and 7 is 14. That gives us 16 electrons available. Okay, so we are going to put beryllium as our central atom. We're going to bond it to chlorine. Chlorine, bond, bond. So we just use 4 electrons, leaving us 12 electrons or 6 pair. Okay. I always fill up my terminal atoms first. So here's 1 pair, 2 pair, 3, 4, 5, 6. So we've used 2, 4, 6, 8, 10, 12, 14, 16, 16. This now count to see if everybody has what they need. This chlorine has 8. This chlorine has 8. This beryllium has 4. Beryllium is okay with just 4 because it only has 2 valence electrons, so it's going to bond on either side. So it's an exception to the octet rule. Also, any molecules that are just made of 2 atoms, such as HCl, Cl2, F2, N2, those are also linear. Now, from here to here, if we had a complete circle, from here to here would be 180 degrees. So it has a 180-degree bond angle. Okay, next up, we have AB3 molecules. AB3 molecules will have a trigonoplanar shape. 3 is tri, 120 bond angle. Your central atom will have 3 atoms surrounding it. It will have sp2 hybridization. Oh, poop. I gotta go back. Dang it.